In this video, I will describe the process I used for installing battery disconnects on my 2018 Airstream Classic. The process I'm going to describe is considerably more complex than those discussed in other videos produced on this channel. Anyone interested in applying this installation to their camper should first have a firm understanding of electrical safety and basic knowledge related to electricity and electrical components. If you are unsure, please consult a professional technician before attempting any alterations to your camper's electrical systems. Now, the reason I did this installation is pretty simple. I destroyed the original camper batteries by allowing them to discharge and recharge over and over. If you haven't seen my video on that, I encourage you to watch that one first. It's called How I Destroyed Two Perfectly Good Batteries. It's installment 2 in my series How I Learned RV Physics and Not Kill Myself. First, let's go over the problem. To help you understand it more thoroughly, I'll start with a simple battery circuit that has 3 main components. 2 batteries connected in parallel, the camper 12-volt stuff, and a disconnect switch. Notice that the disconnect switch is open and no current is flowing. If I close the switch, current flows out of the batteries through the 12-volt camper stuff and back to the batteries. Think of it like a chain of electrons, all linked together and moving at the same time. There must be a completed path for the chain of electrons to move. Now, when on shore power, the converter takes over for the batteries. The converter converts 110 volts AC from shore power into 12 volts DC for the 12-volt components in the camper. For simplicity, I have not shown any switches that could break the flow of current. When battery voltage drops to a pre-selected value, say 10.5 volts, the converter, through a built-in battery charger, automatically sends current back into the batteries to bring them back up to above 12 volts, all the while maintaining power to the remaining 12-volt components in the camper. When the batteries are charged sufficiently, the converter turns off its battery charger and returns to its normal state of powering the 12-volt camper components. The problem with the actual design, in my opinion, is that some components, for example the liquid propane leak detector, are not de-energized when the factory installed battery disconnect switch is pressed. At first glance it seems the right thing to do. When storing the camper, the lights go out, the radio turns off, the multiplex touchscreen turns off, etc. But some things remain on. And given enough time, that small drain on the batteries is enough to reduce their charge to a minimum. To prevent this in the future, I've installed disconnects that electrically isolate both batteries while the camper is in storage. This is a more detailed drawing I've made to show the general connections to the batteries. Now let's color code the wires going to and coming from the battery box. My battery box has 5 large wires and 1 small one. The small one supplies 12 volts to the power jack and is not shown on this drawing. So, there's 2 red wires, 2 black wires, and a white one. Inside the battery box, the red wires connect to the positive battery posts. The black wires connect to the negative posts. The white wire, called the common or ground wire, also connects to the negative post. The ground wire is connected to the batteries to complete a path for 12-volt current between the batteries and the camper chassis. This allows for less complex circuits inside the camper by simply connecting the negative side of the 12-volt components to the chassis instead of running long cables. This is very similar to most cars and trucks. Not all battery circuits are created equal in that your system may not include the white ground wire inside the battery box. Some systems are grounded somewhere between the battery box and the remainder of the camper. If your battery box does not include the ground wire, this install will still work because the batteries will be electrically isolated. I installed these disconnect switches in Mary Jane to solve two problems at once. 1. Clean up the mess inside the battery box. And 2. Install beefy disconnects that would allow me to electrically isolate the batteries from the 12-volt system when I don't need the batteries. Here are the parts that I used. 2 60-amp air conditioner disconnects, 4-gauge wire, about 12 feet, 4-gauge ring terminals to connect the ends of the wires to the batteries, 2-sided Gorilla brand mounting tape, 8 1/4-inch nylon bolts, washers, and nuts. I chose nylon to prevent any galvanic reactions between the battery box, the disconnect boxes, and any metal bolts and nuts. Plus, the disconnect box is very light, so it doesn't need a lot of vertical support. This procedure will install 2 disconnect switches to allow disconnecting 3 circuits. 1 black negative 12-volt DC cable on each side of the battery box, and 1 white ground cable, but only on the curb side of the battery box. Each disconnect can accommodate up to 4 wires, 1 coming in and 1 going out for each circuit being interrupted. In my application, the disconnect switch on the road side of the battery box controls only 1 negative 12-volt cable, so it has 2 wires connected to it. The curbside disconnect switch controls 1 negative 12-volt DC cable and 1 ground cable, so it has 4 wires connected to it. All 3 of these cables, 2 black and 1 white, were connected to the negative posts of the batteries. When I'm finished, each cable will be routed to one of the 2 disconnect switches. Then a new cable will complete each circuit by being routed from the disconnect switch to the original negative battery post. The basic procedure I used was this. Step 1. Remove the batteries from the battery box. Step 2. Route the cable for the power jack, if you have one, out of the battery box and secure it out of the way. I used a bit of duct tape. Step 3. Carefully work all remaining wires out of the battery box. On the curb side of the battery box, there should be 1 red, 1 white, and 1 black. On the road side of the battery box, there should be 1 red and 1 black. The red wires from the positive side of the batteries will remain as is and be placed back on their original posts later. Step 4. Make a paper template of the holes on the back of the disconnect box. Step 5. Using the template and a metal punch, mark the locations for the holes on the outside of the battery box, ensuring there's enough clearance to lift the lid for access to the disconnect switch. Step 6. Drill holes large enough to allow for the 1/4-inch nylon bolts. I used a narrow step drill bit. It looks like this. Step 7. Cut the ring terminals off the 2 black cables, leaving sufficient length to reach into the disconnect. Strip the insulation off the ends of both cables, about 3/4 of an inch. Step 8. Cut 5 lengths of new 4-gauge wire, 3 at 32 inches each and 2 at 16 inches each. The 32-inch wires are needed to reach from where the disconnect switch will be installed to a negative battery post, allowing for routing the wire along the vertical sides of the battery inside the battery box. Routing the wires this way keeps interference with the battery water caps to a minimum. The 2 16-inch wires will become the new battery jumpers to place them in parallel. Step 9. Strip the ends of all the new wires from step 8 above, approximately 3/4 of an inch. Step 10. Attach a 4-gauge ring terminal to one end of each new 32-inch wire. Attach a 4-gauge ring terminal to each end of the 16-inch wires. That's a total of 6 ring terminals. Ensure each ring terminal has been crimped firmly to the wire. I used my bench vise as a makeshift crimping tool. I also wrapped the ends of one of the 16-inch wires in red plastic tape to indicate that it was the positive jumper. Now, start with the roadside disconnect switch. Step 11. Remove the door to the disconnect switch box. It should slide out pretty easily. Step 12. Using a flathead screwdriver, remove one of the knockouts from the disconnect. The hole from the knockout has sharp edges. You may want to line it with a wire grommet or electrical tape to prevent it from damaging the wires. Step 13. Insert the bare end of the new wire through the hole you just made in the disconnect box. Then work it into one of the terminal holes inside the disconnect. Tighten the terminal screw very tight, but being careful not to mar the screwdriver slot. Step 14. Install the freshly cut and stripped existing black camper wire in the paired terminal hole in the disconnect next to the new wire you just installed. Tighten its terminal screw firmly, also being careful not to mar the screwdriver slot. Step 15. On the outside of the battery box, put strips of double-sided mounting tape across the holes you drilled into the battery box. The tape will be between the back side of the disconnect and the battery box for additional vertical support. Step 16. Punch holes through the double-sided tape with a pencil or other sharp tool. Step 17. Insert a 1-inch nylon bolt from the inside of the battery box through the new holes, through the double-sided mounting tape, and into the matching holes in the back side of the disconnect box. Secure each nylon bolt with a matching nylon washer and nut. Tighten firmly, but be careful not to overstress the bolt. The double-sided mounting tape will add to the vertical support of the disconnect box. Step 18. Repeat steps 11 through 17 on the CURBSIDE disconnect switch for the remaining black 12-volt DC cable and the white ground cable. 2 knockouts will have to be removed from that disconnect switch box. Step 19. When all cables have been securely installed in each disconnect switch, check the continuity of the switch between the camper side and the battery side using a multimeter set for resistance. Do this for both on and off positions. Note, on should be 0 ohms, off should be infinity. Step 20. Replace the batteries into the battery box, ensuring the negative posts are paired with each other. In my case, both negative posts are toward the front of the battery box and the positive toward the rear. Step 21. Connect the new 16-inch piece of 4-gauge wire jumper with the red tape from step 10 to the 2 positive battery posts. Connect the red camper wires back to their original posts. If you have one, replace the power jack cable to one of the positive posts. Tighten all the positive post nuts. Step 22. Connect the black 16-inch piece of 4-gauge wire from step 10 to the 2 negative battery posts. Do not put the nuts on the negative posts yet. 23. You should now have 3 black wires with terminal rings, 2 from one disconnect and 1 from the other. Starting with the roadside disconnect, only 1 new wire. Route the new wire from the disconnect through the original cable hole in the battery box, being careful to gently bend it into shape so that it fits along the edges of the battery, and attach the ring terminal to the negative post nearest that disconnect. Step 24. Repeat step 23 for the CURBSIDE disconnect with the 2 new wires. Step 25. When all the negative wires have been installed on the batteries, replace the nuts onto the negative posts and tighten. And that's it. When I finished the install, I verified for myself that the liquid propane detector was indeed energized with both batteries installed, but only the factory installed battery disconnect pressed. The interior lights turned off as expected, and yes, the liquid propane detector was on, as indicated by this red flashing light. This detector is made by Atwood, and according to the owner's manual, the red flashing LED is normal and indicates that the alarm is stabilizing after a power-up. The LED will continue to flash red for approximately 3 minutes. With the disconnects I installed in the off position, the liquid propane gas detector no longer showed the red flashing light, so I believe I have solved the problem of discharging the batteries while in storage. This is what I consider an advanced installation for the average do-it-yourselfer. My apologies for the gross detail, but I hope this helps anyone who might be thinking about a project similar to this on their camper. What I've installed on Mary Jane works well, and I think I've solved the problem of minimizing battery discharge while in storage. Well, thanks for watching. I hope this has been informative, and that if you have any comments or questions regarding this, I'm happy to share my experience with you, so please give me a shout. Here's wishing everyone a great day. I'm Ben, and this has been my Shiny Toolbox.